Hey guys, today we are going to do a little lab virtually. And so we are on page 23 in our notes, and we are going to focus on rectangular prisms and then see what happens when we are dealing with triangular prisms. Okay, so the first thing we're going to do, and I have a bunch of shapes that Mr. McLean can get out for you, okay, is it says looking at a rectangular prism. Okay, so this is just a rectangular one, rectangles on both sides, okay, and a triangular prism. Okay, so we have triangles on both sides. Okay, the first question I want you guys to answer is, how do the areas of the bases compare? So we're looking at just the green. Okay, so I want you guys to write down what you guys think. How do the area of the rectangular prism and the triangular prisms compare? How does their area compare? Okay, so what I notice is that we have a rectangle right here. Okay, and if I look and I compare it, looks like it's the same length, and it goes all the way to the point. So it looks like it would be half of the rectangle. So I notice that the triangle is half of the rectangular base. All right. I'll go ahead and move this real quick so I can change colors. Okay. All right, now what it says is to compare the heights. So here is my shape right here. Here's my shape right here. I'm gonna put them on the hand right here. Okay, how do their heights compare? Go ahead and write down what you guys think how their heights compare. Okay, I notice that they're exactly the same height, so I am going to write they are the same. Okay, so now what I want you guys to do is, before we actually fill this up, because that's what we're doing volume today. How do you guys think the volume of this shape is going to compare to this shape? Okay, there's not a right or wrong answer. I just want you guys to make the best guess that you guys can, okay, using what we've learned so far in 3D shapes. All right, now we're going to test this. So I'm going to take off the base just to make this a little bit easier. Okay. So what I'm going to do is I'm going to fill my triangular one. I'm going to fill it with rice. Doing the best I can. Okay. So here is one triangular prism filled up as best I can, and I'm going to pour it into my rectangular prism. Okay, notice anything? Perfect. Okay, so now what I'm going to do is I'm going to fill it up again because the rectangular one is not full yet. Okay. And it looks like it has been completely filled. Okay, so it took me 2 of my triangles to fill up just a regular prism. Okay, so I'm gonna move the rice real quick. Okay, if your hypothesis was that hopefully the triangular prism should be half the rectangular prism's volume, you are absolutely correct. So it would take 2 triangles to fill up 1 rectangle. Okay, that's what I noticed. Okay, so it says if the volume of a rectangular prism is x cubic inches, so x, how could I figure out, if I was given this, what would be a way to figure out a triangular prism? Well, it took me 2 of these to fill up a rectangular one, so if I know all of this, I just have to cut it in half. So I'm going to take whatever my number is, and I'm going to cut it in half, which is very similar to what we've learned because triangles are half rectangles. Okay. So next thing it says is, could the formula V equals big BH be used to calculate the volume of both figures? Okay, and actually we totally could. Okay, if big B represents the area of the base, okay, so for the first figure, what we did yesterday, it was just rectangular, we find the area of the base, and then we give it height by multiplying by height. But if we have a base that's a triangle, still the area of the base, and then to make it a 3D shape, we would give it height. It could still represent the formula, okay? So yes, it could, as long as we know that we have rectangles and we have triangles, which are totally cool. Triangles we've been comfortable with, okay? So how would you calculate the exact volume of a triangular prism, okay? So first we would find the area of the base, okay? So remembering that the area of a base of a triangle, you would still just multiply the two numbers together, the length and the width, or the base and the height, and then you would cut in half because we have triangles, and now we have this shape, a triangle, and then just to make it a 3D shape, we would lay it flat and we would give it height, so we would multiply by the height, okay? So this thing right here is just representing my area of my base. So we could still use the same exact formula, just knowing that my base is now a triangle, and hopefully you feel comfortable with, triangles, okay? So today we're gonna practice just all these different kinds of shapes that's on page 23, okay? So we have rectangular prisms, we have some triangular prisms, we have some cubes, some more triangular prisms, and then we just have some of these weird, funky shapes, just seeing if you can understand the concept of volume, okay? So I'm going to help you with number 2, and then you guys are going to try the rest of them on your own. Okay, so number 2, we have a prism, and the prism is laid out flat, so it looks something like this. Okay, so the base, again, we have to focus on the base of the shape. So we're looking for the triangles. Okay, so I'm going to highlight the triangles. Okay, and then I have to figure out what the dimensions of the triangles are. Okay, so I notice so I'm asking myself, how long is the triangle? And that would be 6. Okay, and then I'm asking myself how tall the triangle is. The 5 is not, that's the slant height. That's not how tall the triangle is. 4 is how tall the triangle is. Okay, so we do 6 by 4, which is 24. Okay, but it's a triangle, so let's cut it in half, and we get a triangle, the area of the triangle being 12. Okay, so we know that the area of this triangle is 12. Okay, now we have to make it a 3D shape, so instead of area, we're finding volume, so we want to fill it up. So we need to take 12, and we need to multiply by the height of this prism. So again, the height would be how long the 3D shape is, so we multiply by 20. Okay, so 12 times 20 would be 240, and we're talking about feet. But now that we are talking about volume, we're trying to fill things up. So we are talking about cubic feet. We're trying to figure out how many little cubes fit in this shape, and it'd be 240 cubic feet. Okay, so what I want you guys to do today is just kind of focus on, can you figure out the shape? Again, you're asking yourself the base of the shape, no matter if it's a rectangle or a triangle, find the area of the base and then give it height, so multiply by height. Okay, the rest, like 5, 6, 7, and 8 are a little bit more challenging, so I'm asking you guys just to try them, and then we'll go over them tomorrow. All right, I'll see you guys then.